Here's a recap of lesson 29 where we're tackling three-phase power factor correction. Now, three-phase power factor correction is very similar to single-phase. The difference is that just like I have three-phase loads that are connected in either Y or delta, I can have capacitor banks that are connected in either Y or in delta. The equation for power factor correction is still the same. It's still C equals QC divided by omega magnitude of volts RMS squared. Now there's two important details about this equation at three-phase. Number one is that QC must be the single phase difference between the power triangles. That is, if I have my original power triangle, S original, I need to be sure that I'm talking about S one phase original and comparing that to my new S one phase desired. Remember that S one phase in either the original or the desired system is equal to S three phase divided by 3. So this QC that's in the equation must be the difference between Q1 phase original and Q1 phase desired. You can also think of this in terms of the total Q required three-phase to power factor correct the system, and that's going to simply equal 3 times the Q of a single capacitor. What we're saying here is that one capacitor provides a certain amount of QC, and that there are 3 capacitors. So to get the total, you need to sum the contributions of just the 3 capacitors. The second important detail is that VRMS changes based on the connection type of the capacitor bank. If the capacitor bank is connected in Y, what we care about is the voltage across one of the capacitors. In that case, it is VAN. So for Y connections, we need to care about the magnitude of VAN. In the case of delta, we need to care about, again, the voltage across one of the capacitors. And delta, that would be VAB, or the line voltage. So in delta, we need to be using the magnitude of VAB. So that's all there is to three-phase power factor correction. It's the same equation, and you use QC as the required reactive power to power factor correct the system at a single phase. You also remember to change VRMS based on connection type. If it's Y, it's going to be VAN. If it's delta, it's going to be VAB.